Behind the working of an EV are three main parts connected together: the battery, controller, and motor. As it is an electric vehicle, all these parts have electricity flowing through them, unlike their IC engine counterparts. And just like any other electrical or electronic device, EVs need a source of power. For the EV, this happens to be an EV charging station. But forget cars for a second. What do you do when any of your smart devices are about to run out of juice? Probably plug in the charger to charge the battery, right? Well, the same goes for EVs too. EV charging stations can be likened to the USB charging stations for mobile phones available at airports. If your battery is running low at the airport and you don't have your charger on you, you find a charging station to charge your device. EVs can either be charged at commercial charging stations or at the one you have installed at home. Before we continue, let's recap alternating and direct current, or AC-DC. In DC, the electrons travel in one direction, but in AC, the electrons regularly change direction and move back and forth. So if we look at this on a graph, DC would be a straight line, and AC would be a sinusoidal wave that shifts between positive and negative phases. EVs receive alternating current from charging stations the same way our household appliances are powered. And as with any device, electricity has to be converted from AC to DC before it can be stored and used. In the EV, this conversion is taken care of by the onboard charger. Smaller EVs like scooters have off-board chargers. Similar to your mobile phone and laptop, EVs also use a lithium-ion battery pack for its rechargeable edge. But unlike your device that has only one lithium-ion battery, EVs have more than hundreds of lithium-ion batteries packed together under the hood. For EVs, these battery packs boost overall efficiency and offer high energy density, power-to-weight ratio, and temperature performance. In other words, the lithium-ion battery stores an ample amount of energy for its weight. All these put together allow the car to travel greater ranges on one charge. When your battery is charged and you are ready to get going again, you turn the vehicle on and press the accelerator pedal. Now the cool thing here is that depending on how hard you press down on the pedal, the amount of electricity sent to the motor controller varies. So the faster you go, the more electricity is consumed. Okay, let's back up a bit. So if you remember, power from the grid is AC and gets converted to DC for storage in the battery. Before it can be fed to the motor, it needs to be converted to AC again. And once this is done, the AC is fed to the electric traction motor, which then rotates the axles. It is here that the electrical energy is converted to mechanical energy that drives the wheels forward. EVs may have AC or DC motors depending on their application. Larger vehicles are more likely to have AC motors, while smaller vehicles tend to have DC motors. The type of motor used also varies across car manufacturers and models. For instance, Tesla produced the Model S with an AC motor, and the Model 3 with a DC motor. Charging stations are not the only means of charging your battery. When you hit the brakes in an EV, not only does the car stop, the regenerative braking system kicks in. This charges the battery by converting kinetic energy from the rotation of the wheels to electrical energy needed to charge the battery. So, when you're moving, the motor focuses on rotating the wheels, and when you press the brakes, it shifts its focus to restoring energy in the battery. But at times, all the kinetic energy may not get converted into electrical energy because the battery may be completely charged. With all of these parts working together, there is obviously going to be a lot of heat generated. Oftentimes, the battery, motor, and controller may overheat due to peak loads of current and outside temperatures. And this is why a battery thermal management system is in place to ensure optimal temperature is maintained for proper functioning. A glycol coolant flows through the pumps inside the circuitry, absorbs heat, and releases it into the atmosphere. As the coolant has high specific thermal capacity, it is able to absorb heat in a small space. When all's said and done, the EV is an efficient machine that is more than just about saving the environment.